Hello everyone. So from the chapter 7 integrals, we have completed exercise 7.1 where we applied inspection method to find the integral and we had solved 21 questions. Now from the exercise 7.2, we will find the integral of the given function by substitution method and we will solve 46 questions, 39 from the exercise and 7 questions from the examples. So what is the difference between inspection method and substitution method? The main thing is we will find the integral. But by applying inspection method, we can get the integral of the function directly. But in the substitution method, we have to replace the variable x with another variable and then we have to find the integral. So here the direct formula and here we have to substitute and then we have to apply the formula. So when to apply the substitution method? So when we have integral of the combo of function and its derivative as the integrand, then we will apply the substitution method. Function and its derivative. For example, here I have integral of log x into 1 by x with respect to x. So this is what we call integrand. So integral of log x into 1 by x. So if you observe these two functions carefully, this log x is a function. If you differentiate log x, you will get 1 by x. So in this integrand, there is a combo of both function and its derivative. So when you have integrand of this type, we will apply substitution method. So this is the key thing to remember. So now we understood that when we have the function and its derivative, we will apply the substitution method and we will find the integral. But it's not the case every time. Sometimes you will apply it directly. Okay? Sometimes you will do the substitution method in the very first step itself. But sometimes before applying substitution method, you have to simplify it either by applying identities, algebraic identities, or simplifying the trigonometric functions by using formulas like sine 2 theta, cos 2 theta, or by some identities and then apply substitution method. Or sometimes you need to take common. If the variables are repeated, you need to take common and then you have to do the substitution method. Or sometimes you need to cancel out the terms or take LCM. So the intention behind this is some problems are very simple. In the very first step itself, we can do the substitution method, and in some problems we need to simplify and then we have to apply the substitution method. So first we will solve the second question, that is log x the whole square divided by x. Then we will solve the first question because this will help us to gain insight about what exactly substitution method is. Okay. So in the first step we will write what exactly we have to find. We have to find the integral of log x the whole square. So here we have x in the denominator. It is same as writing 1 by x. If you multiply this, you will get back the question with respect to x. So this is what we have to find out, integral of this function. Now if you observe, we already discussed, right? When we have function and its derivative, then we will apply the substitution method. Now there's a confusion which one we have to take for substitution, whether we have to take log x or 1 by x. So for that, you observe this carefully. So when you have derivative of log x is equal to 1 by x, you have to take this original function as t. Okay, not 1 by x. You have to take the original function as t. So let log x is equal to t. So when you are replacing the x variable with t, you are supposed to replace all the other functions carrying the variable x with t. So even 1 by x should also change, even dx should also change. Okay. So we will differentiate this with respect to x. So if you differentiate log x, you will get 1 by x. If you differentiate t with respect to x, you will get dt by dx. So here we have 1 by x dx. So we got for 1 by x. But if we multiply this dx here, then we can replace this entire 1 by x dx as dt. So this will be 1 by x into dx is equal to dt. So now here, before proceeding, you make sure that you have replaced all the functions with the variable t. That is, so 1 by x dx is replaced with dt and log x is replaced with t. So now all the functions in the integrand is replaced with t. So therefore, we'll write the new one. In the place of log x, we'll write t square. In the place of 1 by x dx, we will write dt. So now this is by inspection method. We can say the integral of t square directly by the formula. Integral of x power n formula. So this will be t to the power 2 plus 1 divided by 2 plus 1 plus constant of integration. Now this will be equal to t cube by 3 plus constant of integration. So we got the answer. But here, since we have done the substitution method, we have to get back the original value. So therefore, we will write integral of log x the whole square by x with respect to x is equal to, not t cube by 3, we will write in the place of t we have log modulus of x whole cube divided by 3 plus constant of integration. So why we are writing modulus sign? Because in order to filter out all the negative values, we are putting the modulus sign. So this is like a chain rule. Even if you give negative, you will apply the modulus function, it will become positive, and then you will apply the log value, right? So this is the integral of the given function. So now we will solve the first question. 2x by 1 plus x square. We have to find the integral of 2x by 1 plus x square with respect to x. So here in the denominator we have x square. If we differentiate x square, we get 2x. So we have to take this function as t. But observe carefully, even if you differentiate constant plus x square, you will get 2x. So in the place of constant we have 1. So we can take this entire denominator as t. So let 1 plus x square is equal to t. Now we will differentiating with respect to x. So if you differentiate 1 plus x square, you will get 2x. If you differentiate t with respect to x, you will get dt by dx. So we have to replace this 2x, dx and 1 plus x square. So 1 plus x square is replaced with t. 2x is replaced by dt by dx. But what if we multiply this here? 2x into dx. So this will be equal to dt. So now we got the replacement for the entire numerator, 2x dx and 1 plus x square. So now all the functions with the variable x is now in the form of variable t. So therefore we will write this as 2x dx is equal to dt and 1 plus x square is equal to t. So what is the integral of 1 by t with respect to t? We have the formula integral of 1 by x dx is equal to log of modulus of x plus c. So this will be log of modulus of t plus constant of integration. Yes, now this is by inspection method, right, which we solved in exercise 7.1. So just one step more. Okay. So therefore we will write integral of 2x by 1 plus x square with respect to x is equal to log of, now we cannot write t because here we have the variable x, but in the place of t we have taken 1 plus x square. So we will write modulus of 1 plus x square plus constant of integration. Here modulus of 1 plus x square, if you observe this, 1 is also positive, x square is always positive, because even if you give negative it will become positive if you do the square, right? So 1 plus x square in itself is a positive, and we are putting modulus sign to make positive. So there is no chance of getting negative inside. So what we can do is, we can write this as integral of 2x by 1 plus x square with respect to x is equal to log of, instead of modulus we can write 1 plus x square plus c. We are writing this to make positive, right? When you get negative, to make it positive we are putting this sign, but this can never be negative, so no need of writing modulus sign. So you can just write like this. So log of 1 plus x square plus c. So this is the integral value of the given. Third question, 1 divided by x plus x log x. We have to find the integral of this. So if we observe carefully, we have log x and 1 by x, but because of this plus sign we cannot do the substitution method directly. We have to take common. Here we have x, here also we have x. So first we will take common and then we will do the substitution method. So to find integral of 1 divided by, so I will take x common. So we are left with 1 plus log x with respect to x. So this is what we have to find. Now we will do the substitution method. So we know that derivative of log x is 1 by x. But here we have 1 plus log x. So derivative of 1 plus log x is also equal to 0 plus 1 by x, which is 1 by x. So instead of just taking log x is equal to t, we will take the entire 1 plus log x is equal to t. So let us write 1 plus log x is equal to t. If you just write log x is equal to t, then here you will get 1 plus t. So instead of that, we will write 1 plus log x is equal to t, because we will get the same value. Okay. Now let us differentiate with respect to x. So if you differentiate 1 plus log x, you will get 1 by x, differentiating t with respect to x, dt by dx. So this implies 1 by x dx is equal to dt. Now before moving ahead, just check whether all the x variables are replaced by t. So 1 plus x dx is replaced by dt and 1 plus log x is replaced by t. So all the variables in the given function are replaced by t. So we will write integral of 1 by x dx as dt and 1 divided by 1 plus log x as 1 by t. Now this implies, this is by inspection method, integral of 1 by t with respect to t is log of modulus of t plus c. So therefore integral of 1 divided by x plus x log x with respect to x is equal to log of modulus of, in the place of t we will write 1 plus log x plus c. So here we have to write the modulus sign.